Welcome back everybody to part 2 of our Playable workshop tutorial series teaching you how to make your own game. Before we get started, just want to say a huge thank you to everybody that watched the first tutorial part and the overwhelmingly positive reception that we got on it.
Your guys' comments and messages were some of the nicest things I think I've ever received. It's also been really cool getting to see all of you guys jump into the Discord and share what you're working on and what you're hoping to work on.
Today's video is going to be tackling a big subject, the subject of learning how to code. As a noob, I think this episode is going to be really important to just get a understanding of the foundations of code and the basic parts of the language you're going to use moving forward.
It's really important to us that we don't just give you a bunch of code snippets to copy paste into your project. We really want you to understand these concepts so when you go make your own game, you can just know what you need to do or at least understand the core concepts to work through what you're trying to accomplish.
Yeah, and even like it might get overwhelming to some of you and you might want to skip this episode. That is totally fine, but it's definitely going to be a video that you're going to want to come back to as a reference. Not only will you be able to use this video, but I just also want to mention verbally this time that we also have a companion page for this tutorial series over on our website that Nick put a ton of work into, and I feel really bad that we didn't mention it first episode. So you also have that resource to go to. So with all those warnings aside, let's get started.
And bear in mind that the next 100 pages can get a little bit dry.
So to start learning code in our Godot project, we're actually going to be recreating the character body 3D basic movement template, rewriting it line by line to see what every line does. So where do we begin?
So step one, let's pull up the script editor, which again is at the top of the main area here. Okay, so fortunately we can delete this without deleting it. Yep, we're going to select everything just like you did, and we're going to hit Control/. What this just did is this put these hashtags in front of every line, and in code, or in GD script I should say, this is making everything into line comments. So a line comment is any line of code that starts with a hashtag and it goes to the very end of the line, and it basically means that this line does nothing.
Disables it.
Yeah, it disables it. And the reason comments are super useful is they can also operate as documentation and notes to ourselves and to our teammates. So the other thing about the shortcut we just used, if you were to hit it again while you're on a line like this,
sweet,
you'll see it uncomments it. So this is really handy if you want to just be like, I want this line to not do anything, test something, and then I want to put it back to where it does do something.
I think it's worth noting that also most languages have some form of commenting things out. GDScript happens to use hashtags, but something like C# and Unity will use like slashes.
So the reason that we're commenting everything out is so that we can go through line by line and kind of put things back and then try different things to see exactly what each piece of code is doing. With everything commented out, why don't we try playing our game and see what happens now?
This will be good. I think I'm predicting I did not predict that. The game broke completely. So Nick, you're actually blocking what it just said. So I'm going to move you over here and turn you into your true code Jedi self, where you can teach us properly as the wizard that you are.
Use the code, Jack.
Yeah, exactly. It's so nerdy. It's unbelievable.
It's so bad. So why it was important to get me out of the way is we got to look here for what happened, kind of information. All of our errors and debugging and everything is down here in the bottom panel of Godot.
My evaluator and my profiler, my visual profiler is off the fritz.
And this is a huge part of code.
Things breaking, finding out the problem, finding where the problem is, investigating and solving it.
Yep.
I think that was something that I noticed while I was trying to teach game design to myself using YouTube tutorials was everything's going 100% right throughout the whole thing. Whereas making a game, it's like, try to do something, problem, fix it. Try to do something, problem, fix it. And you learn that way.
And I think that's why a lot of people get discouraged with game dev, right? Because like, you know, something goes wrong, you're like, oh, another thing went wrong. I'm not cut out for this.
Yeah, it wasn't like the tutorial.
Yeah, like this is a big part of it. And it's okay. You embrace the errors, you get really good at solving them. And the better you get at solving them, faster you're going to make your game.
Embrace the errors.
Sorry.
When something doesn't work the way you want it to, the first thing you should be looking for is red text. And you should be looking for it down at the bottom, like you see down here. If you ever get an error message like this, that's like extremely technical, another spot to look is the errors tab right next to the stack trace tab. And sometimes that can have more human error messages.
Yeah, human errors like pipeline cache create.
Yeah, that one's less useful for us. That's an internal Godot thing. But the one after that,
empty script file, that sounds more useful.
That's far more useful. By commenting everything out, even though there's stuff in the file, the computer sees the file as empty. And then the other thing I'll point out is there's a lot of tabs here like evaluator, profiler, visual profiler, monitors. Do not feel like you have to learn all these up front. Even experienced devs a lot of time don't get really good at these tools. These tools all exist to solve specific types of problems.
This is where the bits hits the copper or whatever you guys say.
All right, so let's scroll up to the top of our script file here. Another thing to point out is that when things crash in code or you get a warning, oftentimes it will put some kind of indicator in our code editor, and that's pointing exactly what line went wrong.
This is where your problem is, bud. It's like a financial analyst like looking at your stuff and being like, see, the Starbucks every day, that's what's holding you back.
Why are you revealing my deepest, darkest secrets? On line 1 here, let's uncomment this line. Again, we're going to do that with the control slash. Go ahead and try running the code again. Let's see what happens now that we just have that one line.
We're back.
All right.
Can't do anything, but we're back.
So that's because we're extending character body 3D, which we'll explain in a second. But as far as the computer is concerned, we've met the minimum criteria for our script for it to let us try to run our game. Before we go any further on what extends character body 3D even means, we should probably point out the crazy colors that have been applied to the different words that we have here. Jack, you know a bit about this. Why don't you go ahead and explain it?
Man, this so feels like I just got called out in high school. Like, Jack, you did the homework assignment and know exactly, like, what is it? And me being like, I didn't do the homework assignment and I actually can't explain this. But I think I know where you're going with this. Let me undisable these guys. All these colors are used for syntax highlighting, and the colors are used to visually identify that these things do things differently than the other colors. Is that enough of a dumb answer? Like, is it, that answer is just not dumb enough to keep the tutorial moving?
That's a fine answer. They just kind of exist to help us group things together so that when you're looking at, pages full of text, you're not just looking at black and white, right? Because it's hard to know where to jump to or create these sort of visual patterns in your head that make it easier to navigate the code and get an idea at a glance what it's doing. But it looks super intimidating when you first start.
Yeah, it makes things look extra complicated and kind of cool in that nerdy tech way.
The numbers were scary.
So the first word on our line here is extends, and it's highlighted in red. In GDScript, that means that this is a keyword. I'm going to throw a little bit more theory at everyone. I know this is like drinking from the fire hose here, but this will really help us explain everything that's going to come next. So in English, we would have things like nouns, which are people, places, things. We have adjectives, which are descriptive words for describing nouns. And then we have verbs, which are defining actions or something happening. Well, in programming, we have declarations, which is us telling the computer something exists and information about that thing. We have statements, which are the things that actually cause something to happen most of the time, or they change the flow of code. And then we have expressions, which their whole job is to produce values. As we move forward, we'll kind of use this to create sort of a Mad Lib system to help you identify the patterns of reading code. For example, 5.0 is an expression because it produces a value, right?
Yeah.
And the value it's producing is 5. And when you have an expression that produces a value that's exactly what you see, we call those literal expressions because it's literally 5.
Yeah. And trust me, this is actually like super important. A month into me learning game design with Nick, I was like, what is a declaration that this thing is telling me I don't have? And it's like, I should have learned that on day one, but these tutorials didn't cover that. That's why we're trying to front load it here.
On line 1 here, this extends. This is a declaration. We're telling the computer that our script file extends character body 3D. So the very first thing we did, it falls under that declaration category. All right, so for extends to make sense, I gotta hit you guys with something a little heady. Just we're gonna jump right into it. Every file in GDScript is something called a class. And to understand what the heck a class is, basically it groups together a bunch of other code, and it kind of operates like a blueprint. Think of a class like a blueprint for a house. When you use the blueprint to build a house, like you create a house, and we call that house an instance.
Yep.
If you have a neighborhood of 5 houses all using this blueprint, then you have 5 instances.
Yep.
So in this case, our player script is creating a player class that we can use to create a player or players. So the unique thing about classes in programming is that they can extend other classes, and that lets us kind of build up what those classes can represent or do. A good analogy that we often use to teach this is pretend we have a class called animal, which is just representing any kind of living organism that breathes oxygen and is multicellular. Then we can extend that with our mammal class. So a mammal extends animal, and mammals have fur. And they also are warm-blooded and don't lay eggs. Then we have the class of dog, and dog extends mammal, right? Which means that dog is both a mammal and an animal. But we also could make a class called dolphin, which is also a mammal and is also an animal, but a dolphin is not a dog because dogs have legs and dolphins have flippers.
Are we sure?
So we can actually see this more visually inside of Godot. So if you click on character body 3D in our scene tree panel, and then we look at the right-hand side at our inspector panel.
So I'm going to take a guess here. According to our example, our character body 3D would be a dog. I'm going to skip a couple. A node 3D would be a mammal, and the node would be an animal. So this is all the same thing. It's just extending the traits of these previous things.
Exactly.
This is used to make objects faster instead of coding everything from like the base node class. And I think even if you hit the plus icon up here, you can kind of see this chain of command. Like if I wanted to put something quickly into the game, I'm like, I don't have to go from just a node 3D. I can already go into collision object 3D, physics object 3D, and get character body 3D. In this case, we're trying to build a player. So I can just jump all the way into there, and then we're at that step in that process of creating that thing.
This is actually the biggest thing a game engine offers you, is a bunch of pre-built code to do these sorts of things. So you don't have to write all that yourself, which is a ton of work.
I almost wonder if you can think about it like there is invisible code that extends thousands of lines above this to get to this part. So we don't have to rewrite that every time we're getting to this object.
So let's go ahead. Let's uncomment, all the way down to line 4. Shockingly enough, this is the first time we're seeing an abbreviation inside of our script file,
which there are many of in the coding nerdverse.
Yeah, programmers love to give things very specific names for minute changes or use shorthand for things because we don't want to type constant every time we need.
It's more efficient technically.
Why waste time? Say lot word when few word do trick.
So const is short for constant, but really you shouldn't be learning constants first. You should be learning about variables first. So we're going to change this to being a variable. All you need to do for that is change the keyword of const to var, which is again short for variable. And then we're going to want to change speed to be lowercase.
So why would we want to do that? Why is the capitalization important?
So this is a sort of implicit rule called a convention. Specifically, this is a casing convention. The goal is that it makes the code, when shared across projects, feel similar, feel the same. There's oftentimes a little bit of meaning that might be associated with things. And there's a bunch of different casings. GD script largely is going to use this lowercase with underscores for variables and function names and all the other stuff we're going to get into. And we call that snake case. There's a different kind of casing we're going to see used, which is this sort of all capital style. That's called Pascal case or Pascal case. And I'll throw a graphic up on screen here of all the different types if you guys are interested, but that's the set of conventions that we're going to be using inside of Godot.
And I've come to find that something like using a constant that typically is all capitalized is really convenient because you could be 100 lines of code down in a thing and see something like this, direction.x times speed, speed all caps, knowing that, oh, that is a constant. That way you can know it right there as you read it instead of having to go all the way to the top where you set that variable.
Yeah, you nailed it. So this keyword var, this is how we declare a variable or tell the computer that we're going to make a variable. Variables are super important in code, so we're going to make sure that we cover this pretty well.
If making a game involves peanut butter and jelly, this is your peanut butter. And then we'll get to the jelly in a second.
To understand what a variable is, think of it like a box. It's a box that can hold a value. Next, after the var keyword, is the name that we want to scrawl on the side of the box so that when we have a room full of boxes, we can find the box with the value that we care about in it.
So right now it would be labeled speed.
Yep, the equal sign, and you won't always have one of those when you declare a variable. The equal sign in this case is called the initializer. And what that means is we're going to take the value on the right-hand side and we're going to put it into the box we defined or declared on the left-hand side. When a variable is declared in a file like this, when there's no indentation in front of it, we actually call this a property.
The same word or the same symbol can mean something different depending on its location. It'll get a different definition.
Yeah, there is some context sensitivity. Where else do we have properties, Jack?
In the inspector.
But we don't see speed showing up here in our properties panel right now. And that's because speed is a code-only property at this point. We actually could show it in our property panel, and this could be really useful if you're building kind of like systems for yourselves or for maybe other people on your team that aren't as technical and they want to customize like the character's speed on a per character basis or something. To do this, we can add something to our variable declaration, which is called an annotation. We have a special annotation we can use called export. To make an annotation, we actually start with the @ symbol, and then you're just going to type export. And you'll notice that on the right-hand side now in your properties panel, you should see a player heading for your player script, and we see speed, which we can customize.
It's kind of interesting to know with the inheritance, by the way, that this is showing officially our inheritance now, player. This is what you have inside of your own script, your custom script now.
Yes. If you click into that box and you set a value like 10, even though our code is still set to 5, this player will now move at a speed of 10. So we kind of overrode the initial value. We put a different value into the box by default. And you can see that we get the little reset icon, meaning we can actually hit that and reset back to our default value of 5. So let's go ahead and uncomment line 5. So we'll move down to the next line,
Chugga. Let's go.
and we're back to another constant. And now that we know what variables are, constants are going to be really easy. Constants are just a variable that never changes. It's a box that has something in it, and that box will always have that thing in it. All right, so let's go ahead and uncomment line 7, 8, and 9. Read that error message there.
So you have an error at
9:45. Expected indented block after function declaration.
Hey, look at that. We have our word declaration showing up. This is a function declaration, and that's why we have func. Func is short for function. And this is the other, probably most important thing in programming.
This is the jelly to our peanut butter.
Almost all programming languages have variables and functions. There are some that don't, like brain, but we're not learning that today, and it's horrible.
You say brain? If anybody is wondering, this is where the term edgelord comes from.
Yo, what if we made our code language named brain?
Hey, what if you just didn't do that?
So functions are where we start writing our code that actually does stuff. Because variables just hold data. They don't really do anything with that data. That's what you have to use functions for. In this case, we're declaring that we have a function named underscore physics process. And then we have all this other crazy looking symbol stuff happening after that.
Yeah.
I think it's going to be better to start with a much simpler function.
Okay.
And come back to this one. So go ahead and comment this one out. The other one you're going to see a lot is going to be underscore ready. On line 7, we're going to go ahead and type func. We're going to tell the computer we're declaring that we have a function. We're going to give that function a name. It's going to be underscore ready. And we're actually going to ignore the code completion here because I think it's good for you guys to type this for yourself a few times.
Feels good to rough it and just type it ourselves like men or women.
So ready. And then you're going to do parentheses and then colon. All right. So we're going to hit the enter key and then hit tab to make an indentation.
It actually automatically did it for me.
Perfect. GDScript is something called a white space significant language, meaning the tabs or spaces at the beginning of each line is actually really important for the computer to determine how to group those lines together. You're going to see this a lot with statement blocks in particular. That's when we have a bunch of instructions, each on their own line. Functions hold a list of statements. So that's that second word that does something.
We're declaring the function up here. Now we're about to write the statements of what it does.
And the first statement we're going to learn about, which is necessary for GDScript, is pass.
Our first pink word.
Pass is, well, it's just a placeholder. It literally does nothing. Functions don't actually do anything just because they exist. Something has to trigger them, which we call calling a function. So something has to call the function, and then it'll run all statements or instructions that are inside of it. Ready is a special function that Godot is going to call for you on the nodes. And this function is called the moment that the node this script is attached to enters the scene and is ready to go.
It doesn't necessarily only mean when the game starts. It's when it appears in the game.
Let's start writing some new code here. So you're going to delete pass. We're going to go ahead and write print, and then we're going to put the parentheses. And why don't we just put speed in between the parentheses? So we're going to basically do a lookup, find a box named speed, and then pass the value of that box along to print. Let's go ahead and try playing our game. Let's see what this did. Doesn't look like anything happened, but something did happen.
Oh.
We got to look in the bottom left here, the bottom panel, and you'll notice output's highlighted.
Yep.
Right? So we're on this output tab. This is our console. Print is a function defined somewhere in the bowels of Godot. And its whole job is to print to this console and is a way for us to basically talk back to ourselves from our code. So that 5.0, what value is that?
5. But it's speed.
Let's try making a new function above our ready function. So that's going to start by doing the func keyword. So we're declaring that we have a function and we got to give the function a name. So let's just do get boosted speed. Do underscores in between. Let's practice that snake case we talked about earlier. And then we're going to do the parentheses. So if we were going to take in values that we could use as arguments for a function or parameters or whatever, that's where we would do it. But we're not going to do that right now. So go ahead and do a colon. And then we're going to go to the next line. So we're going to start adding statements to our function. And we're going to introduce a new statement. And this is really important. So this one's going to be return. So right now it's fine. It's happy enough, but we're not doing anything still. So
Much like pass.
Return, yeah, kind of. It is doing something, and that's going to be important later. But in this case, return is kind of like a special magic word that says when you hit this, exit the function. And right now, we're exiting the function with nothing. So if there was code below this, it wouldn't work. It would do nothing.
If there was code not below this, but below inside this function where it's tabbed in.
Yes, and that's a good call out. So go ahead and do like print speed directly under this return. So when this return is hit, this print speed will not work. Let's return something. So we're going to return speed, and then let's change speed a little bit. So this is boosted speed. Let's just times it by 2. And you're going to use the ampersand for multiply. So on line 12, replace speed, and we're going to replace speed with get boosted speed. And we do want the parentheses exactly like you have, because get boosted speed is a function. We want to call that function. And now when we play our game, let's see what comes back.
Beautiful. 20.
We see 20 because we have, I forgot we had 10 in the property panel.
Yeah, right. Over here.
That's an example of how we made get boosted speed. And when we call that, it's an expression because it's producing a value. And this also demonstrates why we have functions in the first place, which functions let us build reusable pieces of code. Like imagine that maybe there's a more complicated calculation you needed to do for get boosted speed. We can kind of group that together and then we could reuse it all over the place if we needed to.
I don't know the return thing still. Because like, couldn't you basically make this function out without this? Could I do print speed times 2?
No.
What's wrong with that?
So the print function says, I return void. I return nothingness.
But we passed it speed.
We gave it something, but it gave us back nothing.
But if this is alone,
Right.
and it gets 10, I'm telling you, Nick,
It
it's not
does.
nothing.
It gives back nothing. It produces nothing. It does talk to the console.
It gives nothing, and it writes to the console.
Yeah.
20 minutes later.
I think what you're saying is, this is like where it's like really weird. Okay, so it's like
The whole thing
Wait,
doesn't
wait.
give a value.
It doesn't have a value, like, because I think almost like this, the fact that this is a number is almost a bad example. I'm thinking it's a value because it's 10, but it's like it's a separate thing. It's going to the console and just printing 10. It didn't give us a number to multiply by. Could I do this instead? Speed times 2 inside of there?
Exactly.
I'm a freaking genius. We're learning, baby. Oh my gosh, I felt so many levels of Einstein. Like I was going into like relativity. Yeah, that felt really good to figure that out though. That felt really good.
Good.
Yeah.
Yes. And that's the aha moments. Like the more you figure those out, like that's really what gets you addicted to this stuff and helps you crank through it.
Sorry to put a little end cap on that. I was like, why are we using return here? We could have done this, but return is used to like break the function.
Return is used not just to break the function, but to also return something out of the function. 20 is being made right there.
Yep.
But we're not doing anything with the 20.
Return is a way of saying, see, I think I'm missing what box it's going into.
That's a great way to put it. So when you said get boosted speed, and you called that function, it's kind of a magic temporary box. And then when we return, it's kind of like putting something into that imaginary box. And then once the function was all done, we swapped the function call with what we put in that imaginary box.
We gave it the box that happens to have that 20 in it. But if we didn't have return, reversing, the 20 would never be put into the box.
Right.
This is like the movie Tenet. Basically, I can catch bullets backwards now.
Yeah. So return lets us quit the function at that point, and optionally, we can provide something back. So we can produce a value that whatever's calling the function can then use.
Okay.
We've talked about arguments. We've seen them used with print, but we should probably actually show how to make those for ourselves because we're going to do that a lot. We're going to go up to the parentheses on line 7, and we're going to define what arguments or parameters we're going to take in. Now, they're actually just variables. They're just called something different because they're in a different spot. And unlike a variable declaration, we don't have to use the var keyword. It's just kind of implied by where this is.
See, I didn't know this.
We're going to take in boost multiplier.
We're making up this word, by the way. You can make it something similar. similar.
Yep. And where we have 2 on line 8, we're going to replace that with boost multiplier. So we're, taking the value in the box named speed, we're timesing it by the value that'll be in our box boost multiplier, and then we're going to return that out of this function to whatever calls it.
In here.
Yep. And you'll notice, go ahead and read the error that's mad at us about.
Too few arguments for get boosted speed, parentheses, because there's nothing in here maybe. I've expected at least 1, but received 0.
There you go.
I think I know what's about to happen. If I put a number here, the multiplier, because we multiply speed right here in our return, not function, but our return statement. I mean, we could do 1 and it would keep it the same, 2 and it would multiply by 2, 3, it would triple it, etc. Am I right?
You are right.
Yes. Good.
Knocking it out of the park. Let's introduce our audience to strings real quick. And we're going to do that by right above line 12. We're going to do another print. You're going to do quotes. And then let's just put a message like about to print boosted speed.
Should we just cover the data types real fast? Like there's only like 5.
There's a lot more than 5. There's the primitive types.
The primitive types, I should say at least.
Yeah, why don't you do it?
Okay, on the fly, let me see if I can do it. All right, an integer, which is a whole number, no decimal point. A float, which is a number with a decimal point. A bool or a boolean, which is a true or false statement. String is gonna be text, like words.
String is any text that's surrounded by quotes. We have to put it in these quotes so the computer knows that it's like a string of characters.
Like we're actually saying these words.
Yeah, that's the core ones. You got it.
Oh, did I get them all?
If you were in C, there'd be character.
Okay, I got them all.
All right, why don't you go ahead and play that real quick, and let's see what happens.
About to print speed, 100.
Awesome. Uncomment line 14. For the rest of this function, I think what we should do is we should do a lot more of a cause and effect thing, because I want to get out of just like sitting in theory land the whole time. We're going to scroll all the way to the bottom and we're going to uncomment the move and slide line. So if you hover over move and slide, go ahead and read definition of this function.
Moves the body based on velocity. If the body collides with another, it will slide along the other body rather than stop immediately. If the other body is a character body 3D or rigid body 3D, it will also be affected by the motion of the other body. You can use this to make moving and rotating platforms or to make nodes push other nodes. But I think it's important to also call it that move and slide is a function made in the game engine of Godot. Like move and slide might not be a part of Unity. Godot has made these functions that they see frequently used in game design in their game engine. So they're like, we're going to make this function for move and slide. We didn't make it. It's somewhere else in the Godot engine that's grabbing it and knowing how to use it.
Let's talk about what the heck physics process is.
Yeah.
Just like ready, physics process is another function Godot gives us, and physics process is going to be called automatically by Godot during each physics tick or each physics frame. You've probably heard the term frame rate or FPS or whatever. I mean, we're gamers here, right?
Yeah.
That's how fast things are rendering. Physics process also makes more sense if we talk a little bit about process. Process is a function that would be called every single frame that your game is rendering.
There is a function that looks like that. Yeah.
Yeah, and why don't you go ahead and just print something out of this function? All right, try playing that.
I think it's going to hit every tick, which is every frame, which is going to be like 60 a second or 120, whatever. I don't know what this thing runs at. I got a 47 in Ti, not a big deal. Like there's so many, you can see it racking up with the exclamation point right there.
It is running at some crazy frame rate, probably 144 frames a second if I had to guess.
Yeah.
And delta, the thing that gets passed to process, that is the amount of time in seconds since the last frame. We use that for frame rate independent movements.
And all this does is like, it makes it so the game doesn't run according to how good your machine can handle running it. There's rare instances, it's usually like in an indie game where somebody didn't multiply something by delta, so the game literally moves faster. Like your character would run faster if your game is running it faster, as in like it's getting 120 frames, but you would move slower if you were running at 60. It's the weirdest thing ever.
The reason we have physics process and process is that physics need to be processed in a very stable way because physics calculations have so much stuff going on. Think about like in most of your games you play today, most of the time, are you getting 144 frames? Sure, maybe, but sometimes you're going to dip down in frames because process is how fast your game is running and rendering things. If your physics calculations are designed to run at 120 frames a second, but suddenly dip down to like 85 frames, then those calculations are going to start to get off, even with delta. So there's some clever stuff going on under the hood that Godot is doing when it executes physics process. Another thing that often happens, and we are going to see this in this series, you might run your physics slower than your game is rendering. Zelda, Ocarina of Time, ran at like 20
24.
frames a second.
Yeah.
Or something, 24, yeah.
Mhm.
So even if you render it at 60 frames a second, your world calculations, your physics, collision detection, your movement, all that kind of stuff is actually happening 24 times a second, even if you render 60 frames, 120 frames, 180 frames, and so on. And we will be replicating that.
So my question is, are we going to use we're writing the player script. It's kind of like a mainstay of like, it's going to be in our game. Are we going to eventually need a function underscore process, or are we just going to use function physics process in a player script?
There will be cases where we'll use function process, but for the most part, you should be doing a lot of your game logic in physics process, especially if your game is tied to the physics system like ours is.
So get the heck out of here, physics process. Yeah. I made sure I said the right one.
Yeah. Let's move on to the first couple lines of our physics process function. We're going to uncomment those and work through them. So we have a new keyword we haven't seen before. We actually have two new keywords we haven't seen before. The first keyword is if, and this is a control flow statement. That's why it's kind of the pink color. And if statements allow us to basically say, hey, we're only going to do this chunk of code below us if our condition is true. And the condition is going to be the thing to the right of the word if and before the colon at the end of the line. Not takes whatever value is on the right-hand side of it and flips it. If the value on the right-hand side is true, then it would be not true, meaning the result would be false. So why don't you go ahead and like read through the condition part of the if statement? That's the not is on floor part. And why don't you figure out kind of what it's doing?
Well, this is kind of funny. We have a thing called is on floor, and that's a medium blue. So that's a function that is also in the Godot engine that's pre-written for us. And it's kind of like, I love these ones that are like, it is just the thing. So it's like, if it's not on the floor, do velocity equal to or greater than? Is that what that means? Or no. No. Velocity, add it to get gravity, which would be gravity, times delta to make everything work right. Which is also weird to me because I'm like, why would we do it here if we already have it up here? Maybe we'll explain that in a second.
So how we would read this is, if we're not on the ground, then we need to apply gravity.
I mean, do we even know what velocity is yet? Velocity
Not really.
is a very faintly not white thing, which is also pre-written, but it's a property. Yeah. It's like it's something in the inspector. Velocity means current velocity vector, typically meters per second. That's using the meter system and not the imperial system, used and modified during calls to move and slide. So it's relating to move and slide, which move and slide is all about the movement of the body based on velocity. Look at that right there.
Let's talk about assignments first, and then we'll talk about the plus sign, kind of throwing a wrench in there.
And then why we have to multiply by delta again if at the start of this function we have delta.
Well, at the start of the function, we're taking in delta. This is where we're actually using delta.
Why don't we have to take in velocity? How do you write this thing just like on the cuff?
Velocity is a property, so it's a box. It's holding some data that's going to be used by move and slide. Go ahead and delete the plus sign on this line. We'll add it back in a moment. So when you see an equal sign here, what we're saying is take the resulting value of the expression on the right-hand side, and we're going to put it into the box on the left. So we're going to put that into velocity. So the plus sign and the equal sign together is a shorthand for saying velocity equals velocity plus get gravity times delta.
So can't I just think about it like this way? You're taking what velocity already is and adding gravity to it.
You got it. We only do that when we're falling. So if we're not already on the ground, then we try to add gravity to fall to the ground. And then once we're on the ground, we don't need to worry about this anymore. There's no reason to keep doing this.
I also noticed that we had an indent after an if statement.
Right. Just like a function takes a block of statements, an if condition takes a block of statements. These statements under this if are only going to run if this check is true. Otherwise, it just kind of skips over them. It just jumps to the next not indented thing. Why don't you go into your 3D scene view and let's just drag our whole player character up. Character body 3D node is selected and then move them up and let's hit play and see what happens.
He gonna drop. Boom.
Boom. Let's go back to our code. Take a wild stab what this code is going to do.
Handle jump. If input is action just pressed, so this function is saying what key is pressed. I imagine. And now it's using quotes to write a string that references in our project settings input map being one of these that it's written as. Well, it's one of these. It's called UI accept. So if the UI accept, which is spacebar, is pressed and it's on the floor, it's gonna jump. Velocity.y, which y is up.
Y goes up and down. Positive Y is up specifically. So we're just setting jump velocity, our constant, which is 4.5.
And the gravity will slow it back down. And then the jump velocity is currently, I'll take it from here, Nick. Is currently capitalizationized because it's a constant, which, are we okay with just leaving right now?
Yeah.
If we wanted to make the jump velocity higher, we could change it up here. So I imagine we're going to be on the floor this time, and we're going to be able to hit the UI accept button, which just so happens to be space, and we're going to fly up 4.5 metric. Nice.
Explaining line 20 just a little bit further, we have, if we press the space bar, that's effectively what the first part is, and we're on the floor. And is another keyword. And what it does is it says, hey, if both sides of me are true, then I will be a true value. If either one is false, then the whole thing becomes false. And then this chunk of code won't run. Let's go ahead and try removing and is on floor and see what happens. So we could jump. But here's the thing. What happens if you just smash the space bar? Just really hit it.
Oh, look at that. I can fly.
Because there's nothing to prevent us from adding more vertical velocity or like more jump force because we never check to see if we're already on the floor. So if you wanted
I wonder
like a double
if,
jump.
I literally was just going to say this. If I wanted a double jump, I would set something that's like, don't activate this if statement until one button press. Or more than one button press is pressed.
You would have to track like how many times have you jumped, right? And then you would reset that once you've hit the ground. I'll provide an example so you can see exactly what this looks like. Put back the is on floor check. We don't want our player jumping around if they're not on the floor. And let's keep moving to the next few lines of code, uncomment lines 23 through 26. So this is where things start to get kind of crazy. Not so much on line 25. We are making a variable or a box called input dir. Dir is short for direction because again, programmers, we don't want to type if we don't have to.
Yep.
And we haven't really talked about the whole input dot thing or velocity dot thing. This is called accessing a member property or function or whatever on some kind of an object somewhere, some kind of an instance of a thing. If input is a lookup expression, it's going and getting a thing, and then the dot says, hey, on that thing you went and got, we're going to call this function. So look in that thing to find this function, and then we're going to call it just like we would call any of the other functions.
The vector would be the direction, but it's getting multiple vectors with the commas.
The commas here are the directions that build up the vector. Vectors are the thing we're going to see a lot in programming in games. They can represent a point in space or a direction of something. Usually they'll be their own type called vector with a capital V, and the number at the end tells you how many numbers are inside the vector, because a vector is just a sequence or a set of numbers. To access each part of that vector, you're going to have a property called X, a property called Y, at least for vector 2, and then vector 3 will extend that by adding a Z property. In rare cases, you might see vector 4, in which case you'll add a W property, but that's the general gist of vectors. There's a bunch of math functions and things on them, and they're used pretty heavily in programming, and we will be talking about them a lot more as the series goes on, but that's all you really need to know for right now. Input direction, we're getting a vector 2, so there's an X and a Y.
Wait,
the X value
why is it a vector 2? Isn't this a vector 4 or 6?
This is a vector 2 because it's kind of like representing a joystick. If you hit A, it's going to be either positive X or negative X, I can't remember which. And then if you hit D, it'll be the other way. If you hit S, the positive Y, and if you hit W, it's going to be the negative Y. And then the next line, the direction, this is where we're taking our player input and we're transforming it by our player's transform. We are not going to get into this right now. We're going to cover transforms in way more detail in the next episode. Let's uncomment line 27 all the way to 29.
So I'm noticing real quick that way earlier we didn't change the other speeds. I'm going to change that. And I think in the first tutorial we covered this. To change multiple versions of these, I'm going to hit Control D and select these 4 and just retype them to speed, and that'll fix that.
Hit play and let's see what happens.
We're back to moving. Freedom.
Are you noticing anything?
Feels good.
What happens if you stop giving it input?
Whoa! I let go and it was still going.
So what's happening here, once we have a direction, the reason we have this if direction, we're checking to see if direction is not 0. Now there's some magic fancy stuff with vector 3 and being able to use it like a Boolean where it's going to do a check to see if it's not 0. It's just kind of a magic shorthand. Don't think too much into it right now. But we're setting our X and Z, so our left and right and our forward and backward movement based on our direction times our speed, but we're never telling it to slow down. What we need to do is we need to say, hey, when we stop getting directional values or directional input, we need to start moving back towards 0. We need to start decelerating the player character. So we can do that using a else statement. So that's that thing there. So go ahead and uncomment the rest of the lines. And what this is doing is this is another control flow keyword. This says, hey, if that if condition up above me, if it failed and it's jumping to its next thing and skipping all of that code, then run me. But if that if condition doesn't fail, if it does succeed, then don't run me.
Are these pink words almost like trigger points?
So the pink is for control flow keywords. So anything that changes the flow of the code, because usually code goes, this. But control flow means that, hey, we're going to hit this and then we might go somewhere else. This last little bit of code here, basically we're taking this velocity.x equals move toward. We're saying, hey, we're going to set our x velocity to the result of this function call. And this function value.
Sorry, I'm cutting you off.
No, go ahead.
Why is it purple?
Oh, it's part of the global scope. So see how it's global scope dot move toward? That means it's a global function. It's not part of any particular object in the engine. It's like a magic function that's just always available to us.
Okay.
What's happening here is move toward is saying, hey, take our current x velocity, move it towards 0, and do that using our speed value. So however fast we ultimately wind up moving when we're running around, we're going to reuse that as deceleration.
When we stop, does it immediately stop or does it slow down by that speed? Let me test it. No, it stops immediately.
It probably does feel that way because your speed is so high. If you want to see something more exaggerated, what you could do is you could set your speed up to something higher. So put it up to like 5, again, in the property. And then instead of speed for move toward, do something like 0.1. And then make sure to do that for the other property or the other speed property below it. All right, go ahead and try that out.
Ooh, feels like hockey.
Yeah, now it's kind of like you're on ice, right?
Yeah. All right, so I think I can get you back to Unjedi. Boom. So we're back to where we finished on part 1, but this time we wrote the whole thing our own dang selves from Nick. We have been going for 5 hours and my brain is fried, but I learned a lot, and I'm not even kidding. As somebody who's like done this kind of process before of learning it, there is a lot that I needed to refresh on and learn new things or learn them in a different way to like kind of unknot my bad own ideas that have been like implemented or cemented there before.
So if you made it this far, thanks for sticking with us.
If you made it, you are a champion. Yeah, once you start coding, it's like it kind of separates the wheat from the chaff. But thank you so much for listening to us yap on about code, and hopefully you've learned a lot. I really appreciate anybody that's just stuck around this long. This episode was a tougher lesson as far as the difficulty. The next ones are going to feel a lot easier after this because of how technical we got today. And you're also going to see a lot more cause and effect moving forward, where we're actually like implementing code, changes the game, instead of just like, here's a bunch of theories. So
all right, everyone, thanks again for watching. Be sure to check out the companion page that goes along with this video when you're ready to try this for yourself. Be sure to check out our Discord.
And guys, we're learning as we go, so make sure to keep on leaving those comments. If you got encouragement to keep us going or constructive feedback, we appreciate it. Leave it down below, and we'll see you guys in the next one.
See ya.